All right. Let me just make sure the stream is actually on. Push the windows. All right. Ladies and gentlemen, the stream that we have all been waiting for. The stream where, for the 4th time, we're going to get BraneScript actually running and compiling. Though this time it's special, because instead of rushing through the parser and the code gen and not having a fully completed IR, this time everything we really need for the language is already implemented, except for essentially just mostly just syntax sugar. There's nothing like there's some expressions that we don't have implemented. Like if we go to emit R value, like ref, deref, field, all of this stuff isn't, I haven't written it yet, but the backend like stuff to express this is there. So instead of like bare minimum pipeline to get there, instead like we have like control flow and everything working. At least I believe it is. We will find out very much so more if control flow is working or not once we actually get stuff compiling. But I think like phi nodes are set up correctly and everything to correctly generate binaries. And that's what we're going to do today, is actually run our code. Which, monumental moment. Now, another thing is I've decided, as much as I love LLVM, and I'm like probably still gonna write an LLVM backend at some point, I think it makes sense for the default backend of BraneScript from the very beginning to be CraneLift. And this is for multiple reasons. So we do give up I'm not sure if the benchmarks are with optimization turned on, or if it's just straight JITting, but if it's optimization turned on, then we won't lose very much performance at all from using CraneLift, because I wasn't going to turn optimization on LLVM either. But with CraneLift, at worst it's going to be a 14% slower than LLVM, but with multiple benefits, which is one, you don't have to install LLVM to contribute to the project. That is a massive one, because LLVM takes multiple hours on a gaming laptop to compile, and I don't want to like force people to have to do that. I want to make it as easy as possible to contribute to the project. So CraneLift will make it a lot easier for that. A lot easier to manage dependency-wise, and I don't have to deal with, I currently have some unsafe Rust bindings for actually using the particular part of LLVM that I want to, because the rest bindings aren't quite complete in that area. So, several benefits to using CraneLift, all of which are like basically stability and actual JITting performance, which is good. Realized I didn't close Discord, but it's okay. We're on the Brane engine repo, which is fine. So we are gonna grab the CraneLift. Actually, no, we're not going to grab CraneLift quite yet. Instead, we're going to do runtime, Brane, backend, LVM. So can I just do the command at runtime cargo new lib Brane backend Brane lift. Not an editor command. Ah. I guess it's just editor commands. Oh well. Oh yeah, and this is what the intermediate representation looks like currently. I took some time earlier day to clean up the parser a little bit. So that is now more reliable as well and supports comments, comments are nice. Hello. Let's see, runtime, cargo, new lib Brane backend LVM, not LVM, cream lift. Indeed. Rust. Oh wait. I wanted to cargo add crane lift. Oh. Need to fully scope into the thing. Crane lift. There we go. So now we're basically going to be copying a little bit of behavior from my old LLVM backend for this. And just kind of checking how I was handling things. Old days, I did some graphics programming. It was painful to deal with all the null pointers that cause the screen to go back. Yeah, that's how it be. I'm looking forward to... I already have a fair bit of the actual engine portion of all this written in C++, and I'm really excited to go back and deal with Vulkan again, now that I know about two things. One is, like, I'm just a lot more familiar with how memory management works, so I feel like Vulkan's bindings are going to be a lot easier to deal with. I'm a lot more familiar with how concurrency works, so... Wait, did I say LLVM or Vulkan? Vulkan. Vulkan. I'm basically just very excited to try out Vulkan again. As I rewrite, I'm gonna rewrite the engine in Rust. Mostly so that we can connect up with the BraneScript backend, but also because there's a lot of very nice serialization related things that we need to deal with. Okay. So going through this, why do I have allow unused variables on there? Okay, so this is just giant match statement for all the opcodes. Some Brane pointer stuff. Okay, this isn't a ton to re-implement, so I might just start from scratch, and then, yeah, this is only 800 lines of code. We can bang that out in like 4 hours. Especially because I'm expecting crane lift's bindings to be easier to work with than LLVM's. Because LLVM, this is like safe abstractions over a C++ library. Or I guess a C library, because I know that there's C bindings for LLVM. And that's what Rust connects up to. So let me look at how I've defined my backend in the past. I haven't. I just haven't defined the backend. So we're starting from scratch here. We don't have a common interface that we want our backend to follow. So I'm just gonna delete JIT function handle for, we'll delete that for now. I want to see how crane left handles function bindings. And then, right, because that's the whole thing where I was gonna push variables on the stack to functions, but now I've gone the complete opposite direction of just not having a stack at all. And just letting our stack, our engine does use, or scripting language does use the stack, but instead of it being the stack, it's register overflow into the stack instead of explicitly like using stack pointers and whatnot. You can't actually have a pointer to anything on the stack. Yeah, okay. Blank page. I might just get rid of the blank page. Grab this whole deal. And all we need this backend to do is really just, we give it an LLVM module and it gives us functions back. I don't know, right now I have all functions statically compiled. Pipelines are going to be how we do linking for the vast majority of things, but I haven't come up with a good way to designate pipelines. So, like, how to link to pipelines, or even how to call them yet. Like, what does our runtime look like? So for now, we're not even going to worry about linking. It's just going to be a crane lift JIT backend, and then this is going to have one public function JIT. It's going to return a result. And then I'm gonna call this JIT module. I kind of want to return a known Let's wait to abstract this until after we're done with it. So for now, this is going to be just not return anything. Work space anyhow. And we also want to do Brane backend. In advance, so we can link to that later. And then, oh, very important thing. We need to link to Brane core. Wait a second, this is in the same folder, isn't it? Yeah. So that way we can get access to stuff like IR. Hello. No, viewer bot. Be gone. Gonna use Brane. Brane core IR, I believe. This will be anyhow result. I don't know if things working, so I'm just gonna restart real fast. I wonder if it's complaining because it's trying to use the LLVM backend, or check the LLVM backend, but it's not part of Workspace. Now we go to just the straight docs, and we figure out how this works. We should probably find one crane lift usage example. And then go from there. Grain Lift demo by Bytecode Alliance. This looks good. Yep, and then we have the AST. And they have a little bit of branching control flow to try to teach us how to do that. Yep, Crane Lift blocks have basic parameters. This takes place with the phi functions and other IRs. We do have phi nodes, so we're gonna have to figure out if written it all in Pascal would have been completed by now. Maybe, maybe not. Actually, what does the syntax of Pascal look like? I am slightly wondering. Ooh, that is a terminal prompt. That's how you know it's a good language. Oh, this looks like C. I thought Pascal was a functional. No, it's imperative. Okay. Is this one of like the dinosaur languages? Because I know it's old. Okay, yeah. Not quite Fortran levels of agent, but actually, Fortran, Pascal, COBOL. Where does COBOL land? Because I know Fortran is like the dinosaur of dinosaurs. Anyway, I'm getting distracted. Means we'll be able to emit Crane Lift IR. Yeah, I really just need to see how to set up the compiler context in the recommended way to set up the compiler. So this is the JIT. It's our function builder context. This is our cogen context. Separates this from module to allow for parallel compilation. I like parallel compilation. I like the sound of parallel compilation a lot. With context per thread. Which is to data objects what context is to functions. This module is obviously like our output JIT module. So we want to do man, it's gonna keep complaining. It's gonna keep tanking my LSP until I put LVM back in the manifest, isn't it? Fine, I put it back in. Now let me have my LSP back. Build a parse manifest. Oh! I wasn't reading the debug messages. It's actually that my manifest is wrong. It's not Rust's fault. Why not use LLVM? I was using LLVM. The main reason why I'm switching over to CraneLift is two things. Well, I guess three, but two things. The third thing is kind of dependent on one of the other two things. The first one is that I want this to compile on a Quest headset, which is this is a mobile phone. Like, computationally, this is like a gaming phone. I'm about to drop that battery. Okay. This is like a gaming branded phone, which means LLVM would be a large increase to the binary size. It'd be a large increase to the when we are actually JIT compiling things, it would probably be a decent compute load to actually JIT compile stuff. And I'm thinking, like, I should have what I have for this as like the default, just so that, like, at a later point in the project I don't need to pause and write another backend. The other thing is that for other people contributing, LLVM takes like 3 hours to compile on a gaming laptop, and I want it to be like super easy to contribute to the project. So not having to have somebody like deal with the dependency management of building LLVM, because even when you're like using Rust, you still have to manually acquire and set up LLVM and do environment variables and stuff. Like, it always takes me several hours to get LLVM hooked up to a project on a new machine, and it's just a very, it lets you know that it's one of your dependencies a lot. I do still want to have an LLVM backend, at least, so that I can test how well it works, because there is a chance that, like, it's 14% faster than CraneLift on, like, if you're running a PC that can deal with the overhead of JIT, of like initially compiling scripts, which that's what I'm worried about on Quest, is the overhead of initially compiling scripts, because after the LLVM has compiled it, it does compile faster JIT code than CraneLift, but it's getting there. Like, I have a hard rule for myself with this engine, and that's never have a frame hitch ever, basically. So, like, for example, I'm working on a Unity project right now. I'm like a contract developer on it's a virtual Burning Man experience. It's pretty cool. But it's a Unity experience, and even though we're using like additive scene loading and whatnot, it's like, as Unity projects go, it's like a little bit rough in some areas, and let me tell you, there is frame hitching everywhere. And I've been doing my best, because I've been brought into the project midway through its development. I've been doing my best to, like, occasionally when I can, just like pull out the profile and be like, this one like function call of native array to array is causing us 300 milliseconds of GC overhead, and then getting rid of that, and now we don't have a frame hitch every 3 seconds in the home world, and that adds so much in VR. Like, if you're on a desktop, you don't really notice when frames are inconsistent. Europe. It's Europe, that's why there's so many people. But for some reason, I like do decently well at attracting what I assume are European viewers. Yeah. But back to the frame hitch thing. In VR, your view freezing for even like 2 frames. You can sense every single inconsistency with frame rate. So on a desktop, you can get away with frame hitches. Like when you're loading or like initially getting into a scene, like gamers don't care if a level hitches for the first 3 seconds. when you're PC gaming. In VR, those 3 seconds are like, whoa, I am not in VR, I am in a headset, I am in an experimental technology, and then like it all stabilizes and you're good. But then occasionally still you get a frame hitch here and there. No, I'm not gonna say that. My bottle of water, no. But no. So basically, having something very the other thing about LLVM is I'm not sure I can manually control when it does compile, because the compilation system I was using is called ORC, and that stands for on request compilation, which means that kind of sounds like the first time you call a function is when it compiles it. And guess what? That's a frame hitch. I also don't know if I can control the threading of that, or there's a lot of things that I'm unsure about when it comes to like having a lot of control over how much compute I'm using every frame. Because with the engine, back to like my no frame hitches, if I want to have the goal of never ever having a frame hitch, even if like the engine is frozen, I still want it outputting frames to the headset. So the scene might be frozen, but you can still move your head around. Like I want like the absolute worst case scenario of the engine to be it's still rendering. So part of that is being able to record every single resource that the computer currently has. So every limited resource and the amount of that resource per frame that we're using. So that is, of course, CPU time, like how much compute do we have per frame, and keeping our how much we do per frame beneath that with like a certain amount of margin. And if we start going over that margin, that doesn't mean like we start dropping frames, that means we start dropping the amount of stuff we do in a frame. And to know like your it's not just CPU bandwidth, it's also like GPU bandwidth, how long are frames taking to render, and also some things you might not think about, like GPU bandwidth, like memory load bandwidth. So how much data can we send to the GPU per frame and how much data can we send back? Because if we're waiting on that data to be sent, that's like potential frame hitches, unless like our async handling of that is good, which I think a fair amount of that will be handled through async handling of stuff. But yeah, basically just profiling every single possible profilable thing, and then having a knob to turn all of those things up and down. And compilation of scripts and scripts, shaders, all that stuff is like, anytime I like give control over to an external library, there's a chance that that operation is going to take a pretty long time, and we need to be able to account for that. And with LLVM, I think LLVM might do its own threading, which means I wouldn't have control over it. It might conflict with my thread runtime. And CraneLift has manual threading, like context per frame. That's pretty obvious right there. Yeah. So let's fix our manifest. Workspace, anyhow. So oh, it's dot workspace, so it's anyhow. There we go. So we should have an LSP now. maybe. Well, let's see how long Crane Lift takes to build, because LLVM takes literal hours. Crane Lift takes a lot less time, at least to check. Yeah, that takes a lot less time than LLVM to compile, because it does a lot less optimization and, like, doesn't have a build target for every single device on the planet. Which that is a benefit of LLVM, is build target for every single device on the planet. Crane Lift should have enough support. Like, as long as Crane Lift has support for ARM 64-bit, we're good. Crane Lift based WebAssembly support and nightly Firefox on ARM 62. Yeah. We're good. Let the compilation begin. So let me just double check. Did I start nesting modules in... Okay, yeah, we have LSP support again. Yay! I can navigate my code. Did I put functions directly nested in pipelines? No, we just refer to them by ID. Amazing. Which means that I can just do for... For function in modules, functions. JIT function. And now we're gonna have a mutable self-reference because we're not going to have threading yet. This will definitely be multi-threaded in the actual engine, but we're not multi-threading it quite yet. Sorry, I just completely zoned out there. So we need codegen context separate from... So it says context is separate from module to allow for parallel compilation with a context per thread. So what does it mean by parallel compilation with a context per thread? Because in my mind, that means it's like... Does module need to be loaded into context to run? Is that how this works? Is this what runs our module after we've already JIT compiled it? Or is this the storage of the module? Because it would make sense if the context needs to reload the function per thread that it could possibly run on, because that's how you need to do it in WebAssembly. That's another reason I didn't like WebAssembly, was that you would need to reload a module per thread that you want to run that module on, so you can't do like parallel calling of the same function. Which in my system, there are no global variables, no global state. The few intrinsic functions that you are able to call out into will be atomic functions, like atomic aware thread safe functions, and also crash safe functions. Oh, here's our binary. So let's see how this is actually called. So we create JIT, and then we run. What is run foo? So run code, foo code, which is a constant string defined down there. Okay. Sure. Okay, so foo code. We are running that JIT code with these arguments. So let's see how run code is defined. We run JIT compile, we throw a mem transmute into, we memory transmute the function, then we call it. Okay, so we do still have to mem transmute function calls, which is to be expected. So what I care about is this compile function. Then translate the AST into crane left IR. This function has state, it's not. Config pointer type. Yeah. Do we only have one module? Let's see what JIT new does, or JIT default. I think it's default? Yeah, default is what they call, so this is how we initialize it. So we set up all of our flags. Crane lift native builder. So this is crane lift build for our native machine. Hopefully we never get this this message here. ISA. What is ISA? JIT builder. The ISA specific settings may return an error if some of the flags are inconsistent or incompatible. For example, some platform independent features like general SIMD support may need certain ISA extensions to be enabled. I'll definitely have to look into that because I want SIMD. I really want SIMD. I should probably look through all those flags to see if there's anything I actually want in there, because yeah. So what I say is implementation specific. Instruction set architecture. Okay, that makes sense. The instruction set architecture. So what architecture and instruction set do we want to use? With default libcall names. I also want to see what that is. I need to be in crane lift. Oh, this is crane lift code gen. Is that a front end thing? JIT builder. This is probably a crane lift front end thing. This is the front end code gen. That's interesting. Okay, it's under crane lift module. Default names for IR libcalls. A function by this name is imported into the object as part of a external name. What are libcalls? So it's some standard memcopy could be extremely useful. Really like memcopy being part of the default set of JIT operations. But I don't know if I'm gonna do that. Actually, we can add it. there's no way for the IR to represent the actual function calls being my JIT is very locked down, so I don't have to worry about like exposure to functions, I guess, as much. Then we create a new JIT module. Module make context, and then when we compile, do we reference? How often do we reference context? Wait a second. Parallel compilation for the same module is what they're talking about. They're not talking about one module per thread. They're talking about multiple threads per module. Okay, so a module... That's actually crazy. So we could have multi-threaded compilation of one module. So if we have like a massive if we have like an absolutely massive script, which I want to avoid, I want like multiple small modules all getting linked together. That was kind of what I was building the architecture around, but that does bring up the possibility of like, if people are creating massive scripts, I would be able to optimize the engine to be able to multi-thread compile massive scripts. Or only compile a certain number of functions per frame, or... Yeah. Okay. I actually really like that. That's a lot better. I was like, multiple modules per context per thread, and I was like, that's going to be really messy to deal with. Context per thread for the same module, I really like that design. That is good. I like that. Okay, which means I'm gonna kind of follow the same pattern that I did for the compiler, of having a context that we pass through. Because the backend is like, this is the one thing that we have a handle to for all of our JIT operations. So I want subscoped objects for non-global contexts. So in function context, we're going to have builder, so we're going to use Brane lift prelude, then the code gen context is per module, so module is just JIT module. Where's that? So that's crane lift JIT. Oh, is that a separate module I have to install? I did that wrong in so many ways, but we're good. Okay, apparently I guess CraneLift can output full binaries. Like one of the uses of CraneLift that they want to do is I think there's experimental support for the Rust compiler to use CraneLift as a backend instead of LLVM for faster development builds. And that's like ahead of time compilation to an actual binary. So like an actual executable is emitted. Yeah, side effect of doing Brane script this way, I could theoretically output a statically compiled binary of Brane script because I'm already JIT compiling it with LLVM and CraneLift. So all I would have to do is make a static library of the runtime of the language and then do a little bit of connecting between the two libraries to make an executable with the Brane script runtime just embedded. I could do that. I could actually have an entirety of like a language you could use to build executables. It would need a better standard library or the ability to link to clibs. Can you link to a dynamic library multiple times? Cannot dynamically link to a library. You runtime load a dynamic library multiple times. Turn the same handle. Okay, I was like, since my coding language is kind of, this was me going like completely off the rails on like, oh, what if I did output statically compiled binaries? I would need to be able to link to actual libraries from other apparently gen is a reserved word. We'll stick with context. I want to just call that gen, like code gen. Data description is what is to data objects what context is to function. I think this is a module level thing. Here's data description from CraneLift module. Data description might be per thread, but I get the feeling this is how structs are laid out and whatnot. Module with the JIT backend, which manages the JITted functions. Move the JIT module. Function builder context. I might actually pass this. I'm going to grab this. It's weird how my selection highlighting is offset. We have a JIT builder. Then we create a new module from the builder. So I feel like CraneLift backend should store CraneLift backend should store builder. Maybe the ISA as well, but store the JIT builder as part of the JIT backend. And I'm gonna do the same thing they did. Just implementing this as default. And then going through all of the steps except for step for the module. Let's edit this. I'm gonna say module context. I wonder, is function builder context stored of context? Where is builder context used? Create a new function builder. It's only used to create function builders, so function builder context can go, honestly, in here. Where does builder context come from itself? So it's in default and it's just not really used for anything. Which is reused across multiple function builder instances. So we require a mutable reference to it to create function builder. It looks like yes. I don't know the lifetime of that. Of context function module. Context is a code-gen context. So this is a thread-specific context for sure. Which means this builder context is thread-specific. I mean, I can move stuff around later. Since builder context does seem to require a mutable reference to function, I'm just going to, just to be sure, they're in module context. It looks like it does get reused between multiple functions, so I think it's at the module level. I don't know. Append block params for the function params. That might be something I want to handle manually. I'm not sure. We'll see. I'm not going to be using their variable system because I handle SSA form graph creation myself. They're trying to make it easier on me, but I already made it hard on myself. Okay, yep. Function builder does have a lifetime specifier. That's what I was wondering. Yeah, I don't like how translate doesn't have turn value. I really don't like that. No. this code gen context. Persistent data structures and compilation pipeline. What is function? Is that like the current function that we're outputting? The function that we're compiling? Control flow graph of the function. The dominator tree for the function. Want to disassembly with the compiled code. Disassembly would be cool. Okay, let's just jump into it and just see what we need. So when we JIT a function, we obviously want a function context. We want a function IR function. We want a mutable function context. This returns, I guess, just a result. Self JIT function. New model, new builder. The JIT builder, so this is correct. Wait, do I need to do this per module? Can I clone this? Clone is not implemented for JIT builder. Builder for JIT module. Okay. So this is explicitly just can I store any of this? Okay. I'm gonna say is this would be crane lift native. Brainlift, CodeGen, ISA, Builder, ISA Builder. When we say finish, this returns a T. What is T? CodeGen result owned target ISA. So I could do CodeGen result owned target ISA. I think I want owned target ISA here. I guess I'll just leave it unwrapping here. It's honestly fine if we crash super early in the program like that. I'm gonna throw an expect on it, so we at least know why it's crashing. Expect unable to build ISA. So we know if, like, we ship to a new platform, we can just find string unable to build ISA. I guess unable. Anyways, my example failed and it showed me not finding the thing, but it's fine. We're going to go back to this example. Apparently this builder is JIT builder with ISA self ISA clone, because it lets me clone it, because it's just atomic reference counted. Yay, I found somewhere to cache stuff. Yippee! Left module. And I'm gonna see. I don't know how I feel about default libcall names. Don't know how I feel about that. Including default content. Dangerous. It's just a mem copy though. Mem copy is probably not dangerous. Actually, it would be dangerous if I could get pointers in there. But I completely abstracted pointers, so we're fine. Probably. Alright. Thank you for stopping by, little kid, though. It is appreciated. Wrong module. Expected 2 arguments, found 0. This method takes 2 arguments, but 0 arguments were supplied. Func, and then let function context equal a new function context. It means we need a module context module. Module make context. Actually, we should reuse this context for multiple things. Oh, data is all of our constants and whatnot. Okay, so when translate starts, then we do more initialization here, for some reason, instead of in the actual compile function, even though it's a single pass compiler. Target config, integer type, I don't care about that. Every single one of the params in the function. You ever do context new function, or is it just like, yeah, function? Yeah, they could have just embedded this function directly in. Okay, so context has a default initialized function, and then we have to explicitly clear it out when we're done with it. I definitely don't want to call and wrap on this. That is how we do error checking. And then we get straight up machine code. Which I guess if you cast machine code to a pointer, does it become a function? I guess it just does. Because if it's machine code, you have a pointer to machine code, that's the same as a pointer to a function. This is the memory address to jump to. I never thought of it that way, but I guess it works that way. So I could literally read out the machine code instructions as binary. That's actually pretty cool. Hey, that was actually pretty cool. Okay. I think this is... This is like constant variables here. Well, I'm excited to see what I need data sections for. And wondering if I need to manually handle that? That'll be useful when we actually get string literals implemented, because currently we don't have a way to implement string literals. Hello, how goes it? We're just working on actually making our code run. So we have a binary, but we have intermediate representation, but now we're getting it to binary. Okay, so going back to this, basically need need the parameters. Actually, I need to finish building out the function builder. So where is the function builder? The function builder takes, oh. We might actually want to do function builder, like create function context inside of the JIT function. So we would do moot or mod context equals module context. Then we can use the module context to create a function context if we need to. I'm actually going to hold off on creating a function context for now. That way we just don't have to deal with that. So we're gonna say self-JIT function, and it is that easy. Takes two, right, we need to pass in context. Reorder for the win. Okay, so now inside of JIT function, we just do the exact same thing that translate does. So we say let moot builder equal function builder new moot mod context. I'm probably just gonna call this module. So that just reads a lot nicer. And now I am super interested in the function signature for this. Cogen ir function self context dot to the context function. So now, after we have the builder, looks like we actually want to do parameters before anything else. I'm gonna add... Now we need to actually convert from the module to... We need to actually convert from the module into cached Brane, work with me here, please. We're going to convert from IR types to the actual crane lift types, which I don't think we actually need to cache. Function JIT type moot self IR native type and we want to return... I don't know what type we want to return yet. Let's figure it out. I don't have any information on that. Oh, is it because stuff broken? So this is Brane backend crane lift module contact. Yep, module. Found type. This is crane lift type. Okay. Well, they don't tell me how to make types, do they? They're just like, there's the pointer type. And that's not even i64 types, that's just pointer type. You're assuming this is i64 because it's a pointer type. Where's type from? Code gen IR types. There we go. So we want to do types. And then just map from these. Is bool a type? No. Types I8 then. Right. There's no signedness. Oh, did I not? I thought I deleted those. I distinctly remember deleting those. You know what? They're there, so we're gonna support them. So help me, if this is the cause of not being able to compile to quest, I will remove them. Yes, we do have 32-bit pointers. That is not a constraint, because our scripting language will be able to allocate more than that amount and still be able to work with it. Yeah. Wait, no, I don't want to put pointer here. I want to put pointer on the 32. You get a grand total of 256 pointers. Actually, no less than that. That would be 128 pointers with the ability to offset from a pointer 128. So your total address space is 128 bits if it was in there. 256 bits. Unless I did bindings, then it'd, no, that would still be 256 bits. Anyway, I might be crazy. Okay, so now we need to convert from native types Why did they underscore P? Oh, because they don't use it. So for param in function input, we want to do function context, signature, params, push, going to bail, create a parameter with default flags. Special. It's getting a little freaky. Gonna save that for memes later. Struct argument, struct return, struct return. This is exactly what I needed, by the way. This is exactly what I needed. Holy crap, this makes stuff a lot easier. Struct return, struct argument. How do I access the values of those, though? Because I need to edit my intermediate representation to support struct and enum parameters. So I need to figure out how this works later. But I was scared that they wouldn't have a way to return structures. Now, LLVM has a way to return structures. Returns, push, ABI param. Can I just tell it to return a structure and have it handle all of that for me? Struct return pointer. This argument can also appear as a return value for APIs that require a function with a struct return pointer argument to also return that pointer in a register. The caller passes it. Okay. I'm liking crane lift, but I will have to figure out how to manage that later. All right. Okay, we have our function signature set up. And I think I'm gonna change function output to only be one type, because it looks like we will be able to set up CraneLeft to automatically handle the C calling convention, which would be amazing. I wonder if I can do templated extern C functions. Since it's the entry block, it won't have any predecessors. You mean before it? Before the current holder, okay. Do I always need to seal blocks? Or is it just like a, Getting to call this method on every block will cause inconsistencies in the produced functions. Okay. So I basically just need to remember to call seal all blocks once we're done, because it looks like there's a seal all blocks method. Let's see what declare variables does. I wish. There we go. Okay. So for each one of the params, builder block params entry block I, Then declare variable. What does your declare variable do? Declare variable just puts it into that map. Okay. I don't know why you needed to put that. I guess you do call it multiple times. Turn variable. So this just declares every single variable. Okay, we don't need to worry about that. We're not using their variable system. We're using our own variable system because we are fancy. Do phi nodes? Add incoming value from the block. Can basic blocks contain instructions after jump commands? Okay. So this means I need to change up the way my phi nodes work a little bit to make them compatible with converting them to... The way this works, I also need to add a little bit of validation to my own compiler. And the thing is that this actually doesn't change the way my compiler works at all, because I intuitively did it the way that you're supposed to, thankfully. Brane C here. Okay, so I can distinctly remember doing LLVM conditional jumps appending. Okay. It doesn't really matter how it actually does it, I just need to... There we go, control flow. Parse expressions for if, then, else. LVM IR. So you have our entry block. Soon get kaleidoscope that looks like this. Well, you might be probably starting to think, oh no, this makes my simple and elegant front-end will have to start generating SSA format in order to use LLVM. Fortunately, this is not the case, and we strongly advise not implementing an SSA construction algorithm for your front-end unless there's an amazingly good reason to do so. In practice, there are two sorts of values that flow around in code written for your average imperative programming language that might need fine nodes. That involves variables, values. Talk about that in depth. You don't need SSA construction to handle this case. If you're using optimization label or optimization passes, which I am not, okay, so the way that I remembered LLVM working was wrong. I thought it worked like just regular assembly, but this actually makes a lot of different things of the compiler easier. Because I now like understand a lot more about why SSA graphs are... I see the appeal in them. Okay. So we're gonna go to RLIR, and we're not gonna have a jump opcodes anymore. At all. None. Nada. No jump code. So instead of having jump and return as well, we're gonna have something called a termination op. And we're going to drop all of these in here. So we have an unconditional jump. We have a jump if, and we're going to say then else. And then in block. Now, our IR will always be valid. Always. As long as the terminal operator jump operation is set correctly. Actually, I'm going to set the jump operation to return none by default. That will be our default jump operand until we explicitly set it to something else, because that is the least likely to cause problems, I think. We don't have to set like a default value or anything, and it will be like pretty obvious if it is wrong, which is actually what we want. So now, somewhere in here, this document, there is implement display. For terminal operator. But yeah, I have functional programming cooked my brain enough that this makes more sense than assembly code. Like an SSA graph, it's like, you should not define your front end to use SSA code, and I'm like, I was able to pretty quickly write a front end that uses SSA form. Like it wasn't that difficult. After I figured out how to do discriminated unions with intermediate representation, that was hard. discriminated unions are hard. Okay, so now we need to fix the compiler. Well, the front end. Our front end before we get to the LLVM front end. Here we go. Oh, no, that's not what we want to do. And we are going to say what am I gonna say? I need my brain to function. Brain, please function. Right, terminate, return. Actually, I'm just gonna say set termination. Yeah, we will make sure that we always handle it correctly. IR term. We set the block, and then the terminator equals term. We're gonna say match on terminator operand. Actually, you know what? Since I'm having to do that for all of them, actually, there's a much easier way to deal with this. There we go. But yeah, now it is actually like, it is solidly a graph now. It isn't this weird, like, the body of the block can jump. No, it is literally just like, there is no jumping within the body of the block, which that was weirding me out when I was explaining the body, like, basic blocks is like, yeah, you can jump at the beginning, you can jump out of the middle, but you can only jump at the beginning. Because that's wrong. Because I had been taught basic blocks are blocks with no control flow. So, this makes a lot more sense. So we don't need... I think I'm going to keep jump map as a helper, just in case I make jump map not an instruction anymore, and instead have the mapping command actually be in the IR. Oh. That as use size for now. Actually, no, we'll keep it at, we'll turn everything into U32. Because it makes more sense, because that's what we actually store blocks as. We no longer emit a jump map, nor do we need to actually do the block range here. We just do create blocks, and then self set terminator. Okay, so this just does a little bit of type checking for us and helps allocate blocks. Why use JIT compilation over compiling fully beforehand? Because you can't. Since Brane Engine is very much focused on user-generated content and pulling content from a server, it would be amazing if I could just trust people to never upload any malicious code ever to their servers. However, I cannot trust that at all, to any extent. So that means that the scripting language itself needs to be made in such a way that it can't emit any malicious operations, and you can't do that with a binary. So if the way it worked was when you load into a world, you download some dynamically loaded libraries, DLLs, and then you load those at runtime, that would be really, really efficient. That would be most efficient. However, they could put whatever they want in those binaries. And we can't control pointer memory access or anything, so they might be able to grab the current state of the program, reach into variables we don't want them to be able to see, manipulate stuff, and through there get vulnerabilities to RCE your computers, remote code execution, which is the worst class of security vulnerability because it basically lets them use your computer remotely. Not even difficult to be malicious, impossible to be malicious. That's what you want, is for it to be impossible to be malicious. That's the goal. And the scripting language's IR is built in such a way that they can't directly access memory. In fact, it should be mathematically impossible for them to access memory I don't want them accessing. The main attack surface is going to be through whatever API I expose to the functions, but since I'm trying to go pure functional, I'm not directly exposing functions. It's we pass data into functions. It edits that data, and then the function, then the engine reads that data. So that should reduce the amount of potential vulnerabilities, but then there's still what if it's my API surfaces is what becomes the attack vector, rather than the scripting language itself can do whatever it wants to your machine. Which means we can make the scripting language be really, really fast because we don't have to check on what it's doing. Kind of like how Godot has set up and process functions on each script. I'm not quite sure what you're referring to there, or what the setup or process would be in this setting. Basically, the way the scripting language is going to work is we give it data, we say, hey, you have this data, and you can do whatever you want to it. So then it does whatever it wants to the data, and then we take the data back, and then do something with that data, as opposed to letting the scripting language tell our program what to do with function calls. And it will be able to tell the program what to do with the data it returns, but it's not direct function calls, I guess, if that makes sense. For most of everything, I'm undecided on whether I want to let it link to functions or not. All right. We need to find the... I think I want to... I don't like that. There we go. Here it is. So I don't know how to use Git hunks yet. We're gonna rename these to just not emit, because we're not emitting an instruction. We're setting the current block block's terminator. Hello. Yes, it's actually going along very well. We're like really close to having code execution, or code, yeah, really close to having code execution again. And this time with control flow done correctly. And this is the furthest Brane script has ever gone, because before I did have a version of Brane script that had control flow and while loops and templating and all that stuff. But here's the thing. The binary that it would ship was raw LLVM intermediate representation, which wasn't what I was planning to like ship in the end. Like I was planning to replace that with an intermediate representation at some point. But like that is a walking RCE, remote code execution vulnerability, because it's just literal LLVM intermediate representation that gets JIT compiled, literally in RCE. But this time we have our own intermediate representation that we are JIT compiling with proper control flow and everything. So yeah, once this is working, we will have a scripting language that is custom, theoretically faster than WASM even. Literally the fastest scripting language, maybe, possibly. I'll have to run benchmarks before I start saying I made the fastest scripting language. I'll probably make a YouTube video with that as clickbait, which is going to do amazingly well. People love fast code. That video is going to be an absolute banger. What was I doing right now? I was doing something important. Fixing these, probably. Right, I remember what I was doing. I was gonna set the current block to be an option. That way, we can always make sure that we have set current block before emitting operations. And we can also verify that we only emit blocks once, so I can say current block is none. As long as the sandboxing works as well it does for WASM. That's currently the plan. I basically copied most of the sandboxing concepts from WASM, so we should be pretty safe. Mainly, there's no direct memory access, there's not even the ability to call functions out of the intermediate representation right now. If we do, it's going to be a predefined set of functions that you define in the module, so it's nowhere are you ever going to have like the ability to directly access pointers. The language doesn't even have a stack, it only has heap. It does use the stack, it JIT compiles to use the stack, so it's not heap allocating everything, because that would be the slowest thing. Most memory efficient. I don't want to make a garbage collected language. It's going to be semi-garbage collected, but it's not going to be full garbage collected. Memory access is going to be fast. Function calling is going to be fast. Everything is fast. Yes, I abstracted away the stack. So everything that the scripting language does, the intermediate representation is in single static assignment form, so I can directly map it to basically directly map it to LLVM and CraneLift as backends, and then they're able to handle register overflow into the stack. So it keeps as many variables as possible in registers, and then it overflows onto the stack when needed. Now, that does mean it's hard to like pass a reference into a function, because if you pass a reference into a function, you kind of do need to stack allocate that. Or not stack allocate that, but well, yeah, you do need to stack allocate that, so you actually have something to make a pointer to. And since I abstracted pointers, that means we don't actually have the ability to give people a pointer to the stack. Meaning that, yeah, if you want to pass a reference into a function, you have to call alloc for that thing and heap allocate it. And then you can pass the pointer to the heap allocated version of that thing into the function, but I might abstract all of that away with having a memory page bound already that's like purely for just function reference passing like that. So implicitly behind the scenes, it would already have a stack page that is exposed to the module. So it's a heap allocated 16K byte page that it would like be able to drop things onto, so you can pass reference to them into functions. So I might make it so you can do what looks like making references to the stack, but it's not actually references to the stack. And I don't want to have to manage a stack in my VM that's separate from the actual stack. So yeah. Or I might even make a... No, I can't. I can't do that. Because I can't have pointers to the stack. It's like, maybe I'll make an operand specifically for making references to stack things. But no, I don't have the ability to do references to stack things. Anyway, I think it's worth it because it makes stuff... I have no runtimes bounds checking on memory access because of the way I did pointers, which means, yeah, speedy branchless programming. The weird architectural design that might lead to weird complications later? Probably. Probably. Either I'm cooking or I'm not. Instead of set term, we just say... Oh, wait. Wait, did I accidentally Did I accidentally delete my set term function that was supposed to do all the fancy stuff for me? I think I did. Okay, I'm not messing around with get hunks again. Because I just undid a fair amount of work. Indeed. We will not know until we try. This is kind of code flow related things, so I do think these aren't actual errors, these are like code formatting, so we can expect. To be fair, the only kind of VM I've dipped into not very far is the protoflux one, so it's not really my specialty. Curious about your benchmark results later down the road. I'm very excited for the benchmark results. Out of curiosity, how does the protoflux VM work? Because I've dived into the Udon virtual machine. If you value your sanity, don't look into the Udon virtual machine. It is it's a virtual machine. Yeah, so when like all the cyan trigger stuff was going on, I took the time to make my own version of cyan trigger. So I wrote an Udon compiler. I think I can do an unwrap on this and be safe. Because this is, again, not necessarily something that a user can influence. This is purely my code format. But then they fired the guy working on it. Yeah, I remember that. He's hanging out in the basis community now, so you can still run into him if you want to. Yeah. I need to reach out to the VR chat team. They were talking about letting me talk to the Soba dev, and I do want to talk to the Soba dev. I want to see what they're potentially doing different with Soba. From what I hear, it's not like an extension of Udon. It will literally be a second VM in the client, so they can do whatever they want with it, which will be interesting to see. Brooks did a bit of explanations about the Protoflux VM in a few places. Don't know the source right now. It's like their dev livestream that they do. Protoflux has its own stack and heap. Value types are stack allocated. Objects are heap allocated. Okay, so it's very similar to how... I want to say... Do you know if it's a stack machine or if it's a register-based machine? That kind of sounds like it's a... That kind of sounds like it's a stack machine. Code is then compiled into execution list. It's not JIT compiled. I was thinking about maybe adding JIT compilation later down the road. We definitely want to add JIT compilation. Code goes speedy room. Is that not a result? It's not. I'm sure not fully know what that term means. Stack machine. So when you're doing virtual machines, generally there's two different ways that you do them. One of them is register based. So that's where, like, say you have an addition operation, you would usually have 3 operands, and those operands are registers. So you would say, like, take the value in this register and store it in this register. So you have a list of values, and those values just exist. Let's say you have like 16 of them. Maybe there's a way to like allocate more or less, but generally then all of your operations just say use the values here, or put this value into this register. So it's kind of like you have a preset number of buckets, and you mess around with the data in them. And then with a stack machine, what you have is all your operations do is add and remove values from the stack. So an add operation, if you had 2 values on the top of your stack, the add operation would basically eat those 2 values, remove them from the stack, and then it would put the return value of that back onto the stack. And that's how C# works, that's how Java works, that's how most object-oriented, garbage-collected languages work. Like, that's how their virtual machines work. And then you JIT compile that to actual operations half the time. And then I think Lua is a register-based machine. No, I think Lua is a stack machine also. The vast majority of scripting languages are stack machines, because they're really easy to code, and then they have heap allocated objects always. Okay. That's to be expected. Stack machines are the easiest type of virtual machine to create. I have actually never made a stack machine, though. I have always done register-based virtual machines, because I like structures, and I don't like keep allocating everything. So what that usually ends up with is me just always creating register machines or JIT compiling things. Protoflux value types, anything small with fixed length is stack allocated unless you box it. And I'm guessing boxes is, in Rust, box is the pointer type. So I'm guessing that's kind of what they're copying. This doesn't need to be a result anymore. Physically allow you to put a value type on the heap. Yeah, nice. Term op. Set termination. This is basically just an easy wrapper for that. Brooks wants to add WASM support for scripting language in addition to Protoflux sometime. A lot of people don't like graph-based languages. This is true. And then if he wants to JIT compile stuff, he could probably JIT compile or create a transpiler from Protoflux to WebAssembly. The difficult thing with WebAssembly when compiling WebAssembly to environments like Resonate is that scripts need to interact with other scripts, and WebAssembly very much likes WebAssembly binaries to kind of resemble an entire program as soon as you try doing anything fancy. Like, there's no way to, like, pass pointers in and out of it, or pass memory in and out of it, so it's really hard to get it to interact with stuff cleanly without just straight doing, like, a memcopy operation in and out of it. So, there's some things that I'm not really a fan of the notion of, like, oh, with WASM we can compile any language and have it work with the scripting system. No, you have to create bindings for everything for that specific language. It doesn't just magically work with every language. That's not how it works. Wait a second. Set term. We don't want this. Have current block. Yeah, there we go. Then we actually want to set self current block equal to none, because this terminates the block. Actually, we can rename this to end block. Yeah, but the community will do that. That part will likely be open sourced. Probably only make C# bindings officially. C# in WebAssembly. You should not make C# bindings for WebAssembly unless you're writing your own C# compiler, because C# runs in a virtual machine, which means a virtual machine with a garbage collector, which means WebAssembly doesn't have a garbage collector currently. I think there's a proposal for it. I haven't checked on that in like 4 years. But if you want to run C# in a WebAssembly, you have to compile the entire C# virtual machine into WebAssembly and then load a regular C# binary with your WebAssembly compiled C# binary. I know this because I've thought about doing it for like Unity games and whatnot. Yeah. I think the better solution for something like C# is, I think Basis, the Basis project had somebody from like an ex-Valve employee or current Valve employee came in and made a common language runtime interpreter. So CLR? Anyway, whatever virtual machine C# uses, they got their own sort of sandbox runtime for that, which is a much better solution than Udon, and much better solution than compiling the entire C# virtual machine into WebAssembly. Someone will make COBOL bindings. I would love to see COBOL in Resomat. That would be amazing. In fact, some people in the Resomat community are currently working on making a renderer in Godot. Oh. That's right, there's like the weird half and half engine situation they got going on. So are you able to swap renderers when you're working with Resomat? Is that something the community can do? To like Rust so badly. The syntax. Functional programming in a trench coat. Inspired by modern languages like TypeScript. And I'm sorry, I'm brain rotted enough that this is similar-ish to what BrainScript is gonna look like too, is Rust-esque. Because unfortunately, I've brain rotted to like it. I just can't write C syntax anymore. My brain can write C# syntax for some reason. Like, I can mode switch into C# pretty easily. But C++, I like lost the ability to do. Then start block some good. I think I'm going to call this end block jump. Our block has a start and end, since these are aliases. End block jump map. Brooks is currently working on a split Resonate in Unity into 2 different processes. Yeah, I've been keeping tabs on that. So there's not a defined interface. The render hooks into, which in turn makes the renderer replaceable, even if the interface isn't documented yet. So so there's now. Okay. This night is gonna run so fast. This is true, maybe. It depends on where the performance bottlenecks are, because you can make Unity run fast. My suspicion is the scripting language. I'm always kind of like, it must be CPU bound. It might be like the insane amount of bloom on everything. By default, that's also a suspicion of mine. This should not be arranged. Branch blocks. Oh, okay. That's because it's a result. Which, why is this a result? Okay, that actually is a result. Not maybe, it's... Not maybe, it's fast. Resonate is slowed down by Unity's ancient mono runtime. Like, Unity is not designed to host an entire custom game engine inside of it. Yeah, if you're writing an entire game engine, then you need something faster. It's kind of weird. Because here I am, going like, oh, you know, you should be able to get through things with just optimization and whatnot. But here I am writing an entire custom scripting language because I refuse to use something like Lua JIT, even though Lua JIT would probably be fast enough for the vast majority of everybody's needs. But I'm like, no. Fast. Order of magnitude performance game in some areas. Man. I guess with like particle systems and whatnot, I can see that happening. Ah, here you go. I want to have an end block return. Technically, the return type should be part of the function signature and not validated later, so I'm gonna change the IR to only contain a value. This should be valid. Cindy's garbage collector. How old is the Unity garbage collector? Alright. If you are in the Discord, drop it in the Discord. And then I can watch it later. Oh, I forgot to write other files, I think. Option value? Why isn't this updating? Oh, are there... There's other bugs. That's why. That's why my definitions aren't updating. '95. Has Unity been around that long? For some reason I thought it was like the early 2000s that it came out. It makes it older than me too, by a lot. No, yeah, Mono has been around. Oh, true. That would be the Unity garbage collector, it's just the Mono garbage collector. Don't care about that. We want... Not that. We want the compiler. Set the current block to none. Do I use the ternary operator anyway? From flattened. Okay. Yeah, there's some stuff that can actually fail there. Alright, this needs an else block, so... Actually, I need to look at this closer. I'm gonna go through and... finish doing that. No internet. Okay, what was the... Right, phi nodes. I need phi nodes to actually report what block they're from. That way I can translate them back into something that Brane can understand. Come on, internet. Stop crapping yourself. It's fine. Oh, is it going back up? It's going back up. It's thinking about going back up. There we go. Okay. We have a stream again. Let's go. Oh. Alright, I'm doing a struct here just so that, yeah, this just happens. My parents' place, and we're not sure. We think it's the ISP. The ISP is saying that that it's our routers, and neither of us can agree on whose fault it is. So we'll see. We'll see. I kind of want to just I have a router on my desk for doing like Steam Link and whatnot. I'm kind of wondering, like, next time the internet like hard goes out, I might just wander downstairs and swap my router for the house router and see if it is actually like the Euro mesh system, because like they get pretty hot. Why is flame? Display is not implemented for block. I want block phi nodes. As part of when we display function. Up the buffering again? No! Okay, we're nuking Vim. Wait a second. I wonder. No, it's completely gone. Now that is 51 kilobytes. So, you know what we could do? Whatever it is. Aha! You guys want to see a magic trick? Behold! 400 kilobits per second of bitrate. This has to be terrible. This has to be absolutely chunky. Oh, I mean, even dropping router. Which actually, you know what? Screw it. I'm plugging my router into the family router. And cutting off all my siblings' Wi-Fi. Just to see if that fixes stuff. Alright, wish me luck.